Hello, everyone, and welcome. I'm Diogo, and I'll be guiding you through today's webinar on building AI in real-time applications using Confluent and SingleStore. We're glad you are here with us. A few quick things before we start. We're recording this session so you can watch it later again. Everyone is on mute to keep things clear, but don't let that stop you from asking questions. Just type them into the Q&A box and we'll get them at the end of the session. So let me introduce our speakers today. We have Jeremy Hogan, Solutions Engineer at Confluent, and Rohit Vamidipati, Solutions Engineer at SingleStore. So, all right, let's dive in. Rohit, you are the first up.
Thank you so much, Diogo. So let me quickly go over the agenda for today. I'm first going to give you guys an overview of SingleStore pipelines, some of our key capabilities and benefits. Then we'll go into SingleStore and Confluent. After that, Jeremy is going to give an overview of Confluent and some of the key capabilities there. And we'll round off the webinar with a demo of SingleStore and Confluent, building a real-time threat detection using IT network logs. So let's go ahead and kick it off with an overview of SingleStore. So SingleStore is a database in which you can transact, analyze, and contextualize your data in real time. So let's go and dive into what each of these terms means. So when it comes to transactions, SingleStore has an in-memory row store that can do extremely fast writes and fast record lookups. So we're built as a distributed SQL database that is horizontally scalable. So as your data or your data needs grow, you can scale horizontally by adding more nodes. So that's how SingleStore kind of works when it comes to your row-based transactional workloads. On the analytical side, we have a column store, or what we really call a universal storage table, that allows you to perform low latency analytical queries and run these large scale aggregate functions. So typically, when it comes to these large scale analytics, we see sub-second response times, and typically we also see sub 100 millisecond response times with our large scale analytics. So with this column store table, you also get 80 to 90% compression. So this keeps your total cost of ownership of your data down. The final piece is contextualization. This is really around our vector capabilities. SingleStore has supported vectors since 2017. So this is before the Gen AI revolution. And at that time, people were using it for, use cases such as image matching, threat detection, like you'll see today, and so on. We've built out a bunch of new features around this vector, around our vector capabilities, which allow you to build your real-time Gen AI apps as well on top of the database. So finally, Jeremy is also going to be walking you through the integration with Confluent and the key capabilities there. But just to give you an idea, one of the key capabilities that we have is SingleStore pipelines that allow you to ingest data directly from a Confluent Kafka stream. So those are the three main pieces of SingleStore. And so let's go ahead and take a look at how people are using us. Oh, also, I do want to mention you can get 10 to 100 times better performance at around 1/3 the costs. So this is typically what people see when they start using SingleStore. You can also eliminate ETL and unnecessary data movement because you can do all of your OLTP, OLAP, and vector workloads within SingleStore. So this is kind of the whole overview of what SingleStore does. We have fast ingest, which allow you to do those large-scale transaction workloads. And I'll show you today through SingleStore pipelines, which is a native function in SingleStore. You can ingest data from pretty much any source, any of your major cloud providers, as well as HDFS, Kafka, and so on. You can run SingleStore on-prem or in the cloud, as you can see over here. And we also allow you to store many different data types: relational, geospatial, key value pairs, JSON, so on. So regardless of the data source, again, we support ultra-fast ingest, and this is what you will see today. And finally, SingleStore allows you to perform your real-time analytics with the low latency response times and allow you to perform, kind of give that real-time experience to your users when you're building your applications. So I'll move on from this slide. And you can see these are some of our customers. Just to give you an idea, Goldman Sachs is using us for analysis of over, petabytes. I would say 2 to 4 petabytes of unstructured data to perform analysis with 40 millisecond response times. And so on. We have a bunch of more customers over here. Some of the top 10 banks in the US are also leveraging our real-time transactional workloads for their high-frequency trading, and so on. So what are some of the key capabilities of SingleStore? And this is really where we shine. So like I mentioned, we have the real-time ingestion with massive parallel streaming. So when I say parallel streaming, essentially you can ingest the data directly into your database. And since we are a distributed database, you can ingest the data directly into the partitions that where your data resides. So we have real-time ingestion from whatever source as well. So, your major cloud providers, S3, Azure, GCP, HDFS as well. And as you'll see today, Confluent Kafka. Your data can immediately be queried as soon as it's ingested. And this real-time data ingestion also allows you to get that, allows you to perform transforms on that data essentially as it comes in. So you can use a user-defined function or a stored procedure to transform the data as it's being ingested. Furthermore, SingleStore allows you to process more than 1 trillion rows per second through low latency analytics, and you can get performance up to single-digit millisecond response times. So this is giving you 10 to 100 times the performance over legacy databases, even with high concurrencies. And finally, the last piece is SingleStore allows you to power your modern apps through a combination of high volume transactions per second and sub-second analytical query response times. So this simplifies your data architecture since you don't need to do any ETL to get your data moving between different databases that perform different workloads. Furthermore, SingleStore is MySQL Wire compatible. So essentially what that means is you don't have to change your MySQL queries in order to run them in SingleStore. We support multi-model, so any data type that you have, like I mentioned earlier, and you can scale your concurrency from, having one query run at one time to thousands of queries simultaneously. So let's dive into a use case and specifically how this top 10 retailer was using SingleStore. So this is a top 10 retailer, Fortune 100 company with billions of dollars in revenue. And the challenge that they had was essentially their forecasting process was time consuming and had a very fragile architecture with thousands of databases and multiple ETL processes. So this increased complexity, limited scalability, and gave very high costs just for performing simple analytical queries on their data. So it was something like a 1.2 billion row operation. It took 8 hours, and it was consistently failing their analytical queries. So this was giving something like 6 hours of downtime, and that led to something around $1 billion loss in productivity. So essentially what they wanted to do was modernize their data architecture. And so they did a POC with SingleStore, and what were their outcomes? So essentially, when it comes to the POC, during the customer-specific demo, they asked us to ingest 1.2 billion records in less than 30 minutes. And the SingleStore performance was we were able to ingest 3.5 billion rows in 7 minutes. So this was a 1,400% improvement in their desired performance. The second piece was they essentially wanted to be able to do an 820 million row base trailer update in 30 minutes or less. And SingleStore was able to do 830 million rows in 10 minutes. So this was a 1,200% increase over the desired performance. So this is just a quick overview of the things that SingleStore can do. And I'm going to go ahead and dive into one of the key features of SingleStore that you will see today, SingleStore pipelines. So SingleStore pipelines are essentially a tool, a native function within SingleStore that allows you to ingest data, like I mentioned earlier, directly from your HDFS, Google Cloud Storage, Kafka, Azure, S3, so We also have recently released MongoDB CDC and MySQL CDC. So this allows you to capture the changes immediately as they are in the database. So SingleStore pipelines essentially give you streaming ingestion with fast parallel bulk loading, millions of events per second. And typically we see, I've seen cases where people were able to get up to maybe 20 million rows per second on ingest. SingleStore pipelines allow you to transform the data as it comes in. So you want to perform some sort of consistency check or something like that on your data as it comes in. You can utilize SingleStore's UDFs or stored procedures, and pipelines allow you to ingest data directly into a UDF or a stored procedure. We have a built-in create pipeline statement, which allows you to create these pipelines and access all of these cool features with 5 lines of simple SQL. SingleStore pipelines also guarantee transactional consistency with exactly one semantics, and we have support for 4 major data formats: JSON, Avro, Parquet, and CSV. So let's go into the anatomy of a pipeline. So like I mentioned earlier, you can ingest your data from your data source, and essentially SingleStore will pull the data changes from the data source system in one of the 4 major formats as you desire. You can ingest it into a transform that's optional. So that's your UDF or stored procedure. And essentially you insert it directly into your SingleStore tables. So you also have the option to write the data to a Kafka stream using this transform. But using SingleStore's distributed ingest system, you basically get that highly parallel millions of records per second performance on ingest. And this essentially is what powers that transactional workload of millions of records per second that I mentioned earlier. So this is the anatomy of a pipeline. We're not going to be seeing the full anatomy during the demo, but I just wanted to give you a quick overview of what goes on behind the scenes. This is also accessible through the simple SQL statements, and I'll show you the create pipeline statement later in the demo. So there are 2 ways that SingleStore integrates with Confluent. The first is directly within the Confluent portal. When you create your cluster, you can use the sync connector essentially to write data directly to SingleStore. The second way is Confluent integrates directly with SingleStore pipelines for ultra-fast ingestion. So essentially, you create a Confluent topic, you write data to that topic, and SingleStore pipelines will monitor that and pull the data in as it's coming. And that's what we'll see today. You can deploy both SingleStore and Confluent anywhere, on-prem, in the cloud, or hybrid deployment. And the use case that we will actually see today is in IT threat detection, where we have hundreds of events happening every second, and we're going to be doing some vector matching with SingleStore. So we're going to take advantage of real-time streaming data, as well as SingleStore's transactional and analytical capabilities. So you can try SingleStore today by just going to singlestore.com/spaces, or you can pull one of the notebooks from the GitHub repository. And one of the notebooks that we suggest you check out in SingleStore Spaces is this ingest data from Confluent Cloud. Okay, so that's it for me. I'll pass it off to Jeremy. Thank you guys so much, and I'll see you in the demo.
Thank you very much, Rohit. Jeremy Hogan. I'm a staff solutions engineer here at Confluent. Been here just over 3 years, and before that, I was at Citi for just over 5 years doing real-time data integrations and migrations of the sort we'll be talking about today. Next slide, please. So over the last decade or so, there's been a massive movement towards digitization. Mature enterprises are redefining business models, products, and services, all to be centered around unlocking data, whether it's gaining a rich view of a customer's habits so their experiences can be more personalized, or letting customers know what they can get even before they know they want it, or validating the legitimacy of a transaction as it happens in the back end. Newer companies, cloud native, software as a service, are increasingly born around and run on data. Companies are built around the application of data and their ability to innovate, thrive, and emerge competitively stronger. And this depends on how quickly they can discover, understand, and apply their data assets to power real-time use cases. Next slide. As everyone knows by now, data provides the bleeding competitive edge for a lot of businesses today. It's what allows them to build these services that will gain and retain customers on their platforms, personalize the recommendations, driver ETAs, loyalty programs, threat detection or fraud detection, predictive analytics, and more. Consumers are holding a high bar expectation for all of this to occur in real time, as they have an application that they can update their account info. They expect to refresh and see that account info now. They expect if there's fraudulent activity on their card that it happens in the moment so that they can decline via text message and not have to seek a refund or wait for some batch job overnight. So to meet these demands of digitization, many enterprises have evolved and implemented their own data architectures in an ad hoc way, like right alongside their legacy architecture, just repeating a lot of the same mistakes. And this has led to decentralized teams and tech that has unintentionally locked the business value of data in departmental silos separated by technologies or org structure or even turf. And as more data sources become available and organizations become ambitious about their usage of data, they continue to invest more and more tech and more data-centric platforms to bootstrap these systems. Yet they all fail to maximize the full value of their data at the same time. Next slide. So for most companies, this kind of data ends up spread across a bunch of different systems and databases and data warehouses, SaaS applications, queues, file systems, on-prem, cloud. Multiple data sets from different domains need to be fused together. This leads to this diagram, which is really a simplified view of the mess that's underneath, which really means cascading batch jobs, secondhand data. There's point-to-point integrations, stale information. And this means that it's messy and it's not built to be queried or used interactively at low latency and high throughput. None of it's arranged to be correlated or contextualized or easily understood. And it's also rigid and inflexible in that you want to make a change in one system, it has to be evaluated for impact 100 hops away. Next slide. And so, what we've done at Confluent is embrace this notion of, oh, I'm sorry, one more slide. There we go. Is embrace this notion that we want to get everything from everywhere all the time and make it available anywhere else in real time. And so every downstream app user use case wants the freshest and most accurate data, which means real time, and it means centralization. It means a central nervous system of truth around your data. But it's also what allows these companies to build services around their data. Next slide, please. And so we see real-time use cases powered by data stream everywhere in our lives. Like I said, from fraud detection to predictive maintenance on fleets. It's the thing that moves the car around on your ride-sharing application. It's what allows a company like Walmart to tell you while you're shopping online that an item that you were looking at in a local store for pickup has decremented from 2 to just 1, and you better reserve it now. Next slide. Kafka has become the de facto standard for streaming around this. Most of your Fortune 500 companies are using it in some fashion. The predominant use cases are still pub/sub, persisting those messages as a stream of events, and increasingly being able to act on those events as they happen in real time. At Confluent, largely with a product called Flink, which very similarly to SingleStore is massively parallel, high-speed ingress, and can be used in combination with Kafka and SingleStore to create really robust AI systems, like using Flink to do real-time data preprocessing for retrieval, making your queries and retrieval prompts and results more efficient, ingesting and filtering data for anomalies and accuracy, and reducing it to just the fields you need to land in the sink. Low latency requests and dynamic retrieval configuration. And you can even act on that real-time filtering and aggregation as the data is coming in to present some manner of materialized views along the way. Or in the case of generative AI, create a real-time feedback loop such that my conversation is remembered and isolated as a series of conversations where I'm building these prompts over time, not just within the session, but every time that I engage with this Gen AI. And that covers broad cases like augmentation, inference, workflow reasoning, and the sort of post-processing stuff that Rohit hinted at with the validation of the transaction or the application of business logic. Next slide. The problem with this is Kafka is very powerful and Flink are very powerful, but they're not particularly easy to use. And so we've created this data streaming platform, which is available in Confluent Cloud or standalone self-managed in Confluent platform that unifies those technologies, but puts a user interface that makes it very easy to interact with languages as simple as SQL, or you can use JSON to configure things. You can consume messages in any format. You can interact with your operational, analytic, and vector data stores like SingleStore provides all of those functionalities while still preserving important things like data governance and respecting privacy and being able to mask, redact, tokenize, or even encrypt fields on the fly as needed. Next slide. And so all of that translates to the customer in delayed time to value, increased total cost of ownership. We have a Forrester report that says if you try to do the sort of stuff you can do on Confluent Cloud on your own, it's $2.5 million out of your pocket versus just using Confluent Cloud. Next slide. And so we call this the central nervous system, this data streaming platform, where all of those point-to-point connections are decoupled. Producers and consumers don't have to know about each other or care about each other. Data contracts are enforced centrally through a schema registry. It's cloud native. It's complete. We have all of these tools that go above and beyond simple pub sub to everything from tiered storage to easy no-code integrations with your more popular source and sync through Connect, and it's everywhere. It runs from everywhere to mainframe to the cloud, Raspberry Pi, IoT, and all of those can be connected in real time. Next slide. And so this really kind of encapsulates everything that I've talked about at creating, unifying your web and SaaS applications, your data stores, and your IoT into one holistic system where data doesn't just originate in point A and then go to live in point B, but more data originates in point C and that lives in D, and D doesn't know about A, and all of that kind of stuff. Next slide. This translates to those real dollar savings that I talked about, 2.5 million if you try to do everything that Confluent can do in a self-managed environment, or a 257% ROI. I think the demo will demonstrate the power of combining all of this into a real life use case. So with that, I'll hand it back to Rohit.
Awesome. Thank you so much, Jeremy. I really appreciate that. That was a really great overview of Confluent and Confluent Kafka. So let me go ahead and give you guys an overview of the demo. So essentially what we have, and let me change to that tab over here. So let me know if you guys can see my screen. So essentially here is the setup. So we have a bunch of log data from network traffic. We have a machine learning model that has been trained on that data, and it's been trained to label this data as either a benign attempt to intrude on the network or a malicious attempt. So obviously within the malicious attempts, there are several classifications such as brute force attacks, SQL injections, and so on. But we've simplified it down to just be benign or malicious. So what we have is a repository of about 1 million records from a single day of network traffic with labels and embedding vectors. So the embedding vectors are pulled from the machine learning model. This repository of data is going to be used to compare against streaming data that is streamed from a Kafka topic. So this data will contain network logs as well as the embedding vectors for those network logs. So those embedding vectors of the streaming data are going to be compared against the 1 million or so vectors that are present within the SingleStore database. And based on this Euclidean distance metric, using a SingleStore infix operator, we are going to label these streaming events as either benign or malicious. So that's the setup. And so let me go ahead and start the stream. So it's just going to start streaming right about now, and the stream should be open. Okay, so with that in mind, let me go ahead and show you the statements that we're using to collect the data. So the first thing that we're going to be using is essentially SingleStore pipelines to monitor this Kafka topic. And essentially, we're going to create a table which contains the logs as well as, it's just going to contain the logs. And we're going to essentially create some persisted columns that are computed from the logs. So the logs are essentially a bunch of JSON data that are being streamed into this topic. So this is the create pipeline statement that you can use to create your pipeline to monitor that topic and pull data into SingleStore. It's a very simple create pipeline as load data Kafka. You have your URL over here, configuration, credentials. It is pulling in new data every 20 milliseconds, and it's putting it into this table directly. And over here, we have our schema that we have defined for our messages. So let's go ahead and create that pipeline, and we'll go ahead and start it as well. So our pipeline has been started. Let's monitor our pipeline batches. And you can see that this is currently in progress. So let me go ahead and run that again. You can see that we're ingesting a couple of some rows per second. Okay. So now let's go ahead and add some columns over here. So we're going to extract from the logs. We're going to extract timestamp model results. So this is our vector column, and I'm extracting it as a blob. And we're going to also extract the log ID. So let's go ahead and add these columns. So with that in mind, let's go ahead and take a look at our data. So we're just going to create some monitoring dashboards essentially. And first thing that we're going to do is take a look at the number of packets per second. So you can see that we're averaging about maybe 7 per second over here. And yeah, we're back up. Yeah. So you can see we have some real-time streaming data, which is coming into our SingleStore database. The logs contain information about the network traffic as well as the model result, which is being stored as a blob type. And we're essentially just streaming that directly into our database. We're averaging about 7 or 8 events every second. So let's go ahead and stop that. And as I explained earlier, we have our train logs data, which contains about 1 million vectors, and we have our incoming logs being streamed into a table. What we're going to be doing is we're essentially going to be comparing these incoming logs, these incoming vectors, against the train log vectors, and we're going to be finding the closest similar vectors to the ones that are being streamed in. If those closest similar vectors are benign, then the incoming event will be labeled as benign. If the closest similar vectors are malicious, then the incoming data will be marked as malicious. So we have this SQL query over here that is essentially doing that calculation, and it's doing that calculation through a Euclidean distance metric. Okay, so essentially we're calculating the Euclidean distance between this model result, which is a 128-dimensional vector, and the model result, which is stored in the SingleStore database already. So let's go ahead and run that, and we'll take a look at our dashboard that we're going to monitor the threat inference. And so you can see we are labeling our events in real time as either benign or malicious. And essentially, we're updating every 1 second that we have, around 20 events per second happening. So we have 19 benign and 1 malicious event. And as time goes on, you can see that this stream is continually getting updated with new data as it's coming in. And yeah, that is how this looks. So we'll just let this stream for a little bit. And if you guys have any questions about this, please feel free to go ahead and ask them in the chat. So I'm actually going to stop this, and I will go ahead and show you the labels directly from SingleStore. So essentially, we're taking the same query, but instead of putting it on a dashboard that looks like this, we're going to take a look directly at the label. So let's go ahead and take a look at that, and you can see that we have our data that is being streamed in, and we have a bunch of labels as either benign or malicious. So that kind of brings me to the end of the demo. So just to go over the key components here, the first component, of course, was we are creating a pipeline to monitor our Confluent Kafka stream. And we have, it's a very simple create pipeline statement. Essentially, we're loading data directly from our Kafka topic. And all you really need is the configuration, the credentials, and the schema. That's something you can set up in Confluent Cloud. The second piece, of course, was utilizing SingleStore's vector search. In this case, the search that we're using is a Euclidean distance search. And yeah, essentially what we're doing is we're doing around, we're monitoring about 20 events per second, comparing each of those 20 events against 1 million vectors in the repository of data. So we're essentially doing about 20 million vector searches per second in this demo. We are collecting the labels as either benign or malicious, and we're essentially just tracking in real time whether the threat that we have is benign or malicious. So yeah, that's the end of the demo. Thank you so much, guys.
Rohit, should we move to the Q&A section? I have a couple of questions here from the audience that I would like to ask you.
Yeah.
So the first one is SingleStore a vector database? Can you talk a little bit about vector capabilities of SingleStore?
Of course. So SingleStore is a vector database, but like I mentioned earlier, it is so much more than that, right? So SingleStore handles OLTP, OLAP workloads, as well as your vector workloads. And all of this is happening with the data living basically side by side with each other, all your transactional data, your analytical data, your vector data. To talk a little bit about SingleStore's vector capabilities, there are really 3 main components. The first, of course, is the vector data type, right? So SingleStore supports a vector data type, and it's as simple as defining, within your create table statement, you simply just define vector, and then you specify the number of dimensions. So this contains automatic casting between string, between binary, and the vector data type, and it comes with automatic error checking. The second piece within SingleStore's vector capabilities is ANN indexing. So I didn't get to talk about that too much within this demo, but when you have large amounts of data, your vector search performance, especially when you are doing an exact k-nearest neighbor search, typically tends to slow down. So what people do in that case is they build an approximate nearest neighbor index. So there are several indexing options that SingleStore allows. The two most popular ones that we see are IVF-PQ and HNSW-PQ. So essentially, you can SingleStore allows you to build all of these different variations of your inverted file index and your hierarchical navigable small world index. And we have a bunch of modular parameters that allow you to tune your indexes to give you as good recall and as good search performance as you want. So those are 2 important pieces about SingleStore's vector capabilities. Yeah.
I have another question. Can you write out to Kafka using SingleStore pipelines?
Yes, you can write out to Kafka using SingleStore pipelines.
Cool. And the last question here is, can you analyze data as the events land from Kafka, or do we have to do some kind of ETL for real time?
Yeah, you can analyze data as the events land from Kafka. Essentially, like I mentioned earlier, with SingleStore pipelines, you can ingest the data directly into a table, or you can ingest it into a stored procedure or a user-defined function. This allows you to perform your analysis and analyze your data essentially as it's coming in. And that's essentially what we're doing here. We're performing a real-time vector search on these streaming vectors that allow you to label them as they come in as benign or malicious.
Cool. I don't see any more questions, so I think we can wrap this up. I want to thank Rohit and Jeremy for sharing our knowledge today, and thanks to everyone for joining and asking great questions. We will send you the recording so you can revisit any part you want. Hope to see you again in our next webinar. Have a great day.